Hey guys, today we're going to do some basic trig and talk about what exactly it is that you need to know in order to be able to do calculations for forces in trusses. So let's jump right into it. Okay, so up until this point in your math class, you've probably talked about the Pythagorean theorem, right? A squared plus b squared equals c squared. And we use this formula with right angle triangles where we have side A, side B, and side C. We can use it to calculate the length of side C, or sometimes referred to as the hypotenuse of a triangle, right? So as long as we know side A and we know side B, we can calculate that. And on the flip side, if, for instance, we know side C and side A, we can calculate side B. The equation for B would simply be the square root of c squared minus a squared. So I assume at this point in this class that you have at least a decent understanding of how to use that equation and how to calculate using side lengths. But we run into some problems with trusses sometimes where we have to calculate side lengths if we're given an angle instead. Like let's say that I know one of the sides of my triangle and I know the angle. Now that symbol, by the way, is a theta. It's a Greek letter, and we use it to represent angles. Sometimes you'll see the Greek letter phi instead. But let's talk about how we do that. And in order to do that, we use a little memory trick called SOHCAHTOA. And it's got three parts: SO, CA, and TOA. Now, SO stands for the sine of theta equals opposite over hypotenuse. CA stands for the cosine of theta is equal to adjacent over hypotenuse. And TOA stands for the tangent of theta is equal to opposite divided by adjacent. So I'm going to show you how to use these to calculate either your side lengths or the angle. So let's use this example triangle that I drew over here. So let's say we have a triangle that has an angle of 34 degrees. And let's say that this on the other side here, this is 3.6 inches. And I want to know what the hypotenuse of this triangle is. Okay, well, first we need to kind of figure out what side is what. If this is the angle that we are examining, then the side of the triangle that's across from it, or on the opposite side, is the opposite side. Now the hypotenuse, obviously, is the hypotenuse. It's the longest length on a triangle. Then this side down here is the last one that we haven't labeled. It's next to the angle, and so we call that the adjacent side. So every triangle that we deal with that's a right triangle is going to have these three names: opposite, adjacent, and hypotenuse. And if you look at our SOHCAHTOA equations, you'll see those three letters written in there for each one. So depending on what information we're given in a problem, we're going to either use sine, cosine, or tangent. Alright, so for this problem, I am given the angle and I'm given the opposite side. And I'm asked to find the hypotenuse. That means we're going to use sine. So I'm going to set this up with the information that we've got. So sine of the angle, which is 34 degrees, is equal to opposite over hypotenuse. So that's going to be 3.6 divided by the hypotenuse. So I'll just write h. So if I'm solving for h, there's h. H is my unknown. In order to get h by itself, I'm going to use the Mr. Adams's patent-pending lazy method of take the thing that's in the denominator and switch it with the thing that's on the other side. And if we do that, we get h is equal to 3.6 divided by the sine of 34 degrees. Now to do this math, we're going to use a scientific calculator. Make sure that when you use this scientific calculator that it's in degrees. If it says rad, then you probably have a different math class, and just make sure you switch back when you are in here. So 3.6 divided by the sine of 34 should give you a hypotenuse of 6.437. We'll go ahead and round that to 6.44 inches. So now that we have this information, we could calculate the other side if we needed to, the adjacent side. With the hypotenuse, we could use either one of these other two equations to calculate it. We could also calculate the missing side using the Pythagorean theorem. C squared equals the square root, not C squared. B squared is equal to the square root of C squared minus A squared, where B is, not B squared, sorry, B equals the square root of C squared minus A squared, where B is the adjacent side that we're looking for. But since this video is primarily about trig, let's use one of these two equations. So I'm going to go ahead and use cosine here. So, cosine of 34 degrees is equal to, my adjacent is my unknown, I'll just call that A, divided by my hypotenuse, which is 6. Now I'm going to keep a couple decimals here because we did round that for our answer. So I'll call this 437. And A is my unknown. So if I want A by itself, I need to multiply the 6.437 that's being divided on both sides. So if I rewrite that, this cancels. So A is equal to 6.437 times the cosine of 34 degrees. So if I take that and I plug it in, I get that my missing side is 5.337, which rounds to 5.34 inches. So those are my two missing sides that I found using trig. Okay, now I'm going to show you another example, but this time, let's say that I have this triangle here that's got let's say that it's got an adjacent side that is 4.3 inches and an opposite side that is 5.8 inches. And this time, I want to know what this missing angle is. Well, first step, let's look at our triangle and identify what our sides are. So if this is the angle I'm looking at, then the 5.8 is my opposite side, and the 4.3 is my adjacent, and this blank spot over here is the hypotenuse. We don't know what that is. Okay, so given that I know opposite and adjacent, I'm going to use tangent, because that's the one that has O and A in it. So let me write that out. So tangent of theta is equal to O over A, so that's going to be 5.8 divided by 4.3. And in this case, my unknown is theta. Well, theta's got a tangent on it, so how do I get rid of tangent? Well, it turns out that we do the opposite of tangent, which is called the inverse tangent. But we have to do it on both sides. So we're going to take both sides, take the inverse tangent. Well, the inverse tangent of a tangent cancels. So that leaves us with theta is equal to the inverse tangent of 5.8 divided by 4.3. Now, when you do this on a scientific calculator, you need to be careful which buttons you press. So if you look at your calculator, you'll see that at the top left there's a second button. So if you press second and then press the tangent button, it should say tan to the -1 with a parenthesis. That's the inverse tangent function. So if we take that and we plug it into what we've got, that's going to be 5.8, or the inverse tangent, sorry, of 5.8 divided by 4.3. And I got 53.4 degrees as my answer. And that answer makes sense because 4.3 and 5.8, our two side lengths, are actually pretty close to each other. So with a little bit more just in the upward one. So it should be above 45 degrees, so this is a reasonable answer. Okay. One last thing. Sometimes with trusses, like let's say we have joint A, and we have a member force that's acting on joint A that's pointed this way. Let's call it FAB. And let's say that that force happens to be 150 newtons. Well, that 150 Newton force is in two directions. And in this class, and for most of your high school math classes, we don't really deal with two dimensions at the same time. It's easier mathematically to split it into an x force and a y force, or a horizontal force, left-right, and a vertical force, up-down. So we can do that. We can imagine what that looks like if we take this force and we draw two other arrows that connect it. So the upright one here would be our y force, and the horizontal force here, the one laying on its side, is our x force. And when we put them together, we get the FAB, which is 150 newtons. So how do we split this up? Well, as you can see, I drew a triangle, and this triangle is formed by the angle that the force is applied at. So let's say that this angle is 30 degrees. And we want to know how much force is in the x direction and how much force is in the y direction. Well, if we look at our triangle, we can actually make the triangle that we've used for trig. If this is my angle, then Fy is the opposite side. If this is my triangle, Fx is the adjacent side. And Fab is the hypotenuse. So if that's the case, then I could make two equations. For y, I would want to use sine, because I know the hypotenuse, that's the Fab, and y is the opposite. So sine of theta is equal to opposite, which would be Fy. Sorry about that, the bell went off. Anyway, it would be Fy divided by 150, or my Fab. Solving for Fy, that would give me Fy is equal to 150 times the sine of theta. So that's how I calculate my y force. For my x force, the x side is adjacent, so I'm going to use cosine since I'm still dealing with the hypotenuse as well. So adjacent is Fx, hypotenuse is still 150, and you can see it ends up being the same math. For both of these equations, we multiply by 150 to solve for Fx or Fy. So Fx then becomes 150 times the cosine of theta. And these two equations, Fx equals the force times the cosine of theta, and Fy equals F times the sine of theta, these are both fairly standard equations that we can use to calculate how much force is only in the x direction and only in the y direction. But there's a caveat. See, if we have an angle that is actually pointed down, instead, like this, where my angle is not with respect to the horizontal like all the other ones that we've seen before, but is instead with respect to the vertical axis, then things actually flip. Here, we can see that in action here. So this time my y force is pointed straight down and my x force is pointed this way. Well, looking at this triangle, if this is my top angle, then the x force is actually my opposite side, and the y force is actually the adjacent now, and the hypotenuse is still the force itself. What that means is that for vertical axis alignment, that Fx is actually equal to force times the sine of theta, and Fy is F times the cosine. Oops, that's ugly. F times the cosine of theta. Ultimately, it's smart to just draw the triangle and identify your opposite, adjacent, and hypotenuse to make sure, if you're not 100% sure. If it's a horizontal angle, as in it's with respect to the x-axis, then you can just go ahead and use those equations that I gave. Otherwise, double check, make sure that you've got your opposite and your adjacent in the right place. As we work through these in class, we'll get better at this. I would encourage you to use this video as a review, and obviously let me know if you have any questions. But this should be enough information to get you going, and next time in class we'll talk about trusses. So I'll see you then.